BactiDefense. The dense green covering you see here is mold. 2 identical sample squares were placed in this Petri dish, one protected by BactiDefense technology, the other not. As you can see, the mold has completely overwhelmed the untreated sample, while the BactiDefense protected square is free of contamination. Your products will probably never have to withstand this level of severity of microbial assault, but the point remains the same. If you did have to stand up to tough conditions, with BactiDefense, you could. But of course, it is not enough to have this protection if it is only temporary. The same garment that is treated in the lab must also work in real-world applications, and that means rigorous human use, followed by cleaning. The durability of the BactiDefense protection is unique. It is permanently fixed to the application surface. It does not leach, and it does not migrate. It's bonded. This means you can have a high-quality garment with a feature that is more than protection from odor. You can wash it or drench it in sweat. It doesn't come off in water, and it doesn't bleed onto your skin after a hard workout. It remains on the surface where it was originally applied because it is bonded. So how does it accomplish this? It is because of its unique chemistry. With its particular bonding sites, the treatment is applied in an aqueous solution, and upon drying, the release of water facilitates a hydrolysis reaction that forms a permanent covalent bond with the substrate. This alone would result in remarkable durability. BactiDefense molecules then bond with each other, further strengthening the treatment through a phenomenon called homopolymerization. BactiDefense is not the only antimicrobial technology available. There are hundreds and maybe even thousands of chemical substances on the earth that kill microorganisms. Many of these, like arsenic, lead, tin, mercury, silver, and plant and animal extracts, are natural, but can also be highly toxic to people and the environment. An effective antimicrobial for the textile industry can't just kill or repel microorganisms. It must do so safely over the life of the treated product and without negatively affecting people, the environment, or other important characteristics of the textile or other treated goods. These other chemical substances all rely on the same old trick for effectiveness. They are essentially poisoning the microbes to death. This has immediate concerns, as the only effective way to poison microbes is by having an antimicrobial that leaches off the surface of the textile and then soaks the surroundings with the toxin. BactiDefense offers a stark contrast to these traditional leaching materials. First of all, it is not a poison, and it doesn't leach or transfer. Its effectiveness is the result of a physical rather than chemical method of control. Like a layer of swords and spikes, BactiDefense is a barrier upon a surface. The first part is the molecular base. This base is the antimicrobial's anchor. It is anchored by covalent bonds, which are formed readily through hydrolysis reactions that bond our antimicrobial permanently to almost any surface and allow for cross-linking and polymerization with other molecules. The second part of the molecule is a centrally located, positively charged nitrogen. This positive nitrogen plays an important role in the active nature of the antimicrobial. Cell membranes of microbes are negatively charged. When in close proximity, the microbes are drawn in towards the active surface of the antimicrobial and killed. The third segment is the long molecular chain that acts like a sword that pierces the cell membrane of all microbes that come in contact with it. These 3 parts of the antimicrobial combine to give BactiDefense its unique and effective mode of action. Once the antimicrobial is bonded to the surface of an object, it is ready for defense. As microbes come into contact with the surface, they are first punctured by a long molecular chain. The physical attraction between the positive nitrogen and the negative cell membrane draws the microorganism even further down on the sword. This, in and of itself, would destroy most microorganisms. But just to make sure, when direct contact occurs between the negative and positive charges, the cell membrane is electrocuted or blown apart by an electrical phenomenon. Destruction of the cell is quick, complete, and reliable. In addition, since this process does not involve any physical transfer from the antimicrobial surface to the cell, the effectiveness of BactiDefense is never diminished. It remains ready for the next wave of microbial contaminants. To learn about how you can integrate the BactiDefense technology into your products or facilities, visit us at www.BactiDefense.com. We are always pleased to find solutions to your problems with microbes and elimination of odors that you may face in your daily life. BactiDefense, microbial solutions for all surfaces.